This is 724, Graphing Rational Functions, and in this lesson we're going to be able to graph a rational function. Now, when graphing a rational function, it's a good idea to find as much descriptive information first. Then you could put everything together and start sketching the graph. So, what is some of that descriptive information that we know so far? The first is determining the vertical asymptotes and holes. So we look at the domain. Then we want to reduce the function to its lowest terms. It's a good idea to find x and y intercepts. We need to find our horizontal asymptotes. And then plot points and graph. Now you should write this down because this is going to kind of help you do it. But pretty much the key pieces are the vertical asymptotes and holes, horizontal asymptote, and be able to plot points and graph. If you can do that, you can graph these just fine. So let's look at this first one here. So determining the domain, if I factor the bottom, I get the x plus 2, x minus 2, nothing cancels out. So I just have vertical asymptotes at x equals negative 2 and x equals positive 2. So I'm going to draw those in. So I have a vertical asymptote here, and I have a vertical asymptote here. Then I can find my horizontal asymptote, right? Like I reduced it, I found the vertical asymptotes and our holes. I can find my horizontal or slant asymptote. The degree here is 1, the bottom is 2, so it's going to be y equals 0. So I now know my horizontal asymptote. It's going to be y equals 0. Now finding x-intercepts. So remember, to find the x-intercept, you set your function equal to 0. So So 0 equals 3x over x squared minus 4. Okay, well, if I multiply both sides by x squared minus 4, it's just 0. Divide by 3, you get x equals 0. So I know I have an x-intercept here, which also means I probably have a y-intercept there. So if I plug in 0 for x, 0 equals 0. So there we go. So I have my x and y intercepts. So now what I just need to do is literally just plot points. I don't know what's happening in these regions of my graph. And so if we just create an x and y table, you can plot as many points as you need to be able to do that. So what about negative 3, negative 4, negative 5? You just need to plug them in to your function to find what that is going to be, what that's going to be. So negative 3. So that's negative 9 over 5. If I plugged in negative 4, so that's going to be negative 12 over, that's 16, 16 minus 4 is 12, so that's negative 1. If I plugged in negative 5, so you get negative 5 times 3 over negative 5 squared minus 4. So that's negative 15 over 25 minus 4, so 21. And then if you need to, you can enter that in your calculator and get a decimal, right? So that's approximately negative 1.8. And that's negative 1. And this one right here is, approximately like 0.7, 0.69. Right, so you can get these like close approximations, and then you can go through and sketch it. So if I plugged in negative 3, I got negative 1.8. So at negative 3, it's negative 1.8. So about right there. At negative 4, it was negative 1. And then at -5, it was this -0.69, so about right there. Once you get enough points, you just sketch it to where it hugs the asymptotes. Okay, so now let's graph in the middle. So -1, I already have 0 and +1. So if I plugged in -1, okay, I get 1. If I plug in +1, you get -1. Now, this kind of tells me that maybe it's going to go up forever, but I still don't have enough information. So one thing, maybe we can plug in, -1/2 and see what happens. So 3 times -0.5 over -0.5 squared minus 4. And so the idea is going to be, if we did that, we're going to be able to kind of locate that number better. And so that's positive 2.5. 2.57. So I did -1.5, and I got positive 2.57. Okay, so that's about right here. So this tells me that that's probably going to go up there, and then that's probably going to go down there like that. And now on the next one, we need to plot some more points, so I can try +3. If I try +3, this is just going to be +9/5. If I try +4, so if I try +4, +4 is just going to give me +1. And if I try +5, it's going to give me +15/21. Literally just plugging it in for x. So 9/5. So that's going to be right here. And then I have 4 is going to be 1. And then 5 is going to be 5/15. 0.5, there you go. And then you just draw it hugging the asymptotes. And so then you have your graph. I didn't do anything fancy here. Literally, it was just find the descriptive information, and then you just plot a bunch of points. So for this one, find the vertical asymptotes and holes. So that means I'm going to have to factor this. So A times C, -10, factors of -10 that can give me a -3, so -5 and 2. So I'm just doing some quick factor by grouping here. -5x plus 2x minus 5. Factor by grouping, x is in common, and then 1's in common. So this factors into 2x minus 5 times x plus 1. And at the bottom here, this factors into x minus 3 and x plus 2. So nothing cancels out, so there are no holes. But I do have 2 vertical asymptotes at x equals 3 and x equals -2. So let's draw those in. So then we can try the horizontal asymptote. The degrees are the same. So if I divide those, you're going to get 2. So your horizontal asymptote is y equals 2. So you get that value there. So just to save some time, we can immediately go to our x and y table. So I want values on this side, in the middle, and on this side. So I can do -3, -4, -5. the values in the middle would be like -1, 0, 1, and 2. And then the values on the other side will be like 4, 5, and 6. And so all we need to do is just plug them in to our calculator to figure out what they're going to be. And I'm just entering it in myself in my calculator. And so in doing that, I'm just going to write the values. And remember, we're just, like, for example, -3, I'm plugging in -3 in for x. I'm plugging in -3 in for x. So that's what we need to do. Just plug in -3 in for x. So you're going to get 3.66. And I get 2.785. 2.5. -1 is 0. 0 is 0.833. 1 is 1. 2 is 0.75. 4 is 2.5. 5 is 2.142. And 6 is 2.04. So once you have those values, you can go through and start plotting them. So at -3, it's positive 3.66. And then -4 is 2.78. So -4 is 2.78. So 2.78. And then at -5, it's 2.5. Okay, so we sketch it. And then at -1, it's 0. At 0, it's 0.883. And then at 1, it is 1. And at 2, it is 0.75. Okay, so it looks like it's going down here. It's coming up around, and it's going back down there. The only way to truly verify it, and now I've done this a bunch of times, it's one of those things I just know. But if you plugged in, a value like -1.5, and then you plugged in 2.5, that'll verify it. Maybe I'm wrong. You guys should plug it in and see if I'm wrong. And then sketching the other ones, if we plugged in 4, we got 2.5. And 5, we got 2.1. And then really, really close. And they hug the asymptotes. And there's our graph. So in conclusion, what did we learn today? We sketched rational functions, and the way that we graph these rational functions or rational equations is going to be first by finding the important information, so the descriptive information, horizontal asymptotes, vertical asymptotes, holes, and then pretty much the rest of it from there is to create your XY table and plug in a bunch of points and see what your graph is doing. This does conclude our lesson. If you have any other questions, please leave them in the comments.